Hello and welcome everyone. Delighted to have so many attendees and participants on the second day of our Esports broadcast Colloquium, brought to you by the Royal Television Society. The RTS Thames Valley branch, the Creative Technology Center, is putting on this year's Colloquium on the subject of Esports broadcasting. Yesterday, we had our first session with Stephen Claw Jalisi, and Stephen gave a great overview presentation on esports and live streaming and broadcasting. Today, we are joined by Paul Martin from Vecima, and Paul has about a 40 to 45 minute presentation, at the end of which we will take questions from the audience. So as you go along, you have a chat that you can reach us at, and you also have the Q&A area where we would love to get your questions, and they will be taken at the end. So thank you all for joining, and I will hand over to Paul for his presentation. Paul?
Thank you, Anna, and good afternoon or good morning, everyone. So pleasure to be giving this presentation today about content delivery networks, following on from Stephen Jalisi yesterday. As you can see, I'll start with a few introductions to myself and Vecima, so that you get a sense of where we're coming from on this subject, and then talk a little bit about the structure and how content delivery networks actually work, before going into a description of OTT streaming at scale. And this is where I'll be referencing both the live delivery, a bit like we heard yesterday from Stephen on esports, as well as VOD delivery, which of course both appear in OTT. The next subject will be the Scale-Maturity Quadrant. I'll explain more when we get there, but it's looking at how the OTT delivery works as the services scale and get more mature. And then finally, why not finish with a few predictions about where I think things could be going in the future when it comes to OTT delivery. So without further ado, I'll jump into introduction. So just to give a quick sense of my background and how that will play into this presentation, I've had a career in the technology industry, but different sectors. Motorola, British Telecom, and then Snell were the first three companies I spent many years with. So a mix of pull systems from Motorola, which of course as a manufacturing company had them embedded in its way of working. At BT, it was a lot about broadband and OpenReach for those of you in the UK, the access network operator for the UK. And actually I was part of the small team that helped to launch BT TV back in those days. And then at Snell, I ran the playout division. So very much focused on linear playouts. And today at Vecima, what I think of as what we do, which is really storage and CDN solutions, for me, the direct-to-consumer environment that we're in now is really a just-in-time pull system for video playouts over broadband. And so it's a nice combination of the things that I've done previously. And building on what Stephen talked about yesterday, where he talked about esports delivering the live content to the platforms, like Twitch, this presentation picks up from that point and talks about what happens after that in delivering that content to the end consumers. So a little bit about Vecima, really quickly to give you a sense. So we see ourselves as driving content from creation to delivery. We cover three distinct areas within our portfolio with some examples of customers here. So we cover workflow automation in the areas of file ingest, post-production processing, and file delivery. Content delivery with storage and processing and streaming is in the middle, and that's the bit I'm going to focus on today. But finally, we also have products that go into access networks and actually deal with the data and the video that's being delivered to the consumers right out to the nodes in front of people's homes. And the background that we come from as a business contains these three primary brands. Concurrent in the middle is the one, again, that I will be focusing on here, and what Concurrent's done and how that's led into today's CDN environment. So this is not a presentation about the company. Clearly, it's about the subject of OTT and content delivery networks. And just to finally explain the point that that caching layer, which is a part of our portfolio, is something that is where we're focusing our conversation today primarily. So a quick comment about the current situation we're in, and many of you of course see all the headlines that there are about streaming, and it's all about growth. And this chart comes from Cisco in their forecast that they actually released in 2017, and it talks about the distribution of video over the internet and the exponential growth phase that we were going into from 2016 to 2021, which we're of course partway through. And so right now we should be expecting something in the range of 2,000 to 2,500 exabytes a year being delivered. And put that into context, because in 2020, here we are, we're seeing both real growth, some signposts, and some financial updates which show we're on that curve. So a few key stats here that have come out in the last few months about streaming growth. People have been seeing double-digit figures across the world in different ways. Signposts just from recent months, although we've had COVID, some of these things have been in progress already. So BBC iPlayer, a record number of requests in May. DAZN have talked about streaming over 100 events to more than 1 million people on each event. Broadband usage, which is a key part of this, is growing faster than predicted. And then I will focus on this next because it's part of the picture. It's how the fiber to the home expansion affects what can be done with OTT. And just to wrap it up, because the financials always need a close look, is everyone in this space has been reporting expected growth or real growth in their financial results. And I just, again, want to focus that BT point for our UK audience. You know, Openreach talking about spending £2 billion per year on network upgrades. And it's part of the picture of what goes on from that point of origination to the end consumer, which I'll go into in more detail. So I do see it as a key driving force for OTT, which is that the investment being made by big telco operators around the world in their networks is what's enabling more and more people to take on the OTT services at scale. This is from BT's annual report, recently issued, and the focus here is Openreach, which is the part delivering the access network for the UK. And the point to make here is literally that within the capacity and network upgrades, they've been spending between £1.5 and £2 billion per year on expanding and improving the network. And this is where fiber to the home is getting all its investment in the coming years. If I do a comparison between that level of spend and what we can say is the high throughput satellite market globally, in 2017, the market was valued approximately $3 billion with expected significant growth going up to 2023. But I like to think that the telco investment we see from BT is mirrored in most major telcos around the world. And that level of spend, expanding network capacity, is actually going to enable more and more OTT delivery to be achieved as we move into the future. So, with that bit of background, let me get into CDNs, content delivery networks, and talk about how they work at a high level. I should say this is not a deep technical presentation. We're going to talk about the architecture, the principles, how some of the things work within the system. And with that said, there's two concepts to cover first. Firstly, push and pull systems. I'm sure all of you are very familiar with the terminology, but in short, in simple terms, the push system is all about delivering efficiently in a standard way for a standard output delivered to everyone. A pull system, on the other hand, is intended to deliver customized or tailored output also very, very efficiently. So as a concept, this is something we do see in OTT and how the CDNs have to respond. The other concept, which is one, again, you all easily understand, is the concept of a many-to-many relationship within the ecosystem. So the first example there, simple consumer phone call model. If we're trying to connect people around a country, around the world, the network will connect an individual to any number of other individuals. But that's happening on both sides of the fence. In broadcasting, it's the same. The broadcasters can deliver to video platforms, and aggregate their content, but each video platform receives from many broadcasters, and each broadcaster delivers to many video platforms. And in OTT delivery, at the level of the CDN, it's the same concept. So many OTT operators are using multiple CDN platforms to deliver content. And those CDNs are connecting to the internet service providers, ISPs, in each location they're serving customers. They're the networks we're connecting to as consumers. And so again, there's a many-to-many relationship. So a single ISP connects to multiple CDNs, which does include the very open internet peering platform, which doesn't have any CDN infrastructure within it. So these concepts are just important as we move forward. So what is the content delivery platform, let's call it? And on this diagram, some simple points. On the left, we have the live stream or the file delivery coming in. On the right, we have the consumer with their device and the player and client, which is actually receiving that video stream. And in the middle, we have a transcoding cluster, which is handling the adaptation into ABR formats, let's say. We have an origin cluster, which is generally handling the packaging and internet-facing side of the CDN delivery. We then have a storage cluster, which is in use in a video scenario for VOD or for look back or for time shifting TV, what we might call the live cache. And then we're out into the intermediate and edge sites where content caching is happening. And I just want to make it clear for the sake of this call today, we divide, the left-hand side is the origination platform, the right-hand side is the CDN. And I'll be talking mostly about, therefore, the CDN today. But let's first talk about the interaction between these two parts and how the consumer engages with this infrastructure. So first thing to mention is that the scale is different in each environment when it comes to streams. As you'd expect, the CDN is handling maybe millions of requests from millions of consumers, while the origination platform generally is handling tens to potentially thousands of requests, with the goal that the CDN delivers the majority of the traffic without having to revert back to a request, a pull, in other words, from the origin. And let me just walk through that quickly. So the way it works is the consumer makes their request for the stream. Perhaps it's a HLS format, 5 megabits per second. So that request is made. If that particular stream doesn't yet exist inside the CDN requests back to the origin sends that stream once authenticated, etc. At that point, the CDN does two things. It delivers the stream all the way to the consumer, and it caches the content so that it can be, as the request numbers 2, 3, etc., come in, it can deliver the vast majority of the requests back to the consumers without needing to refer back into the origin environment. And this is, of course, what caching is all about. And it's about how to make networks efficient and not transfer video or data routinely across a network when it already has been requested. It's worth noting that in those streams, as they come to the consumers, they're unicast streams, they're tailored, they can be tailored. That's why we're in a pull model and why OTT can handle the targeted advertising, etc., extremely well, is that ad insertion takes place inside that stream through the cache environment. Yes, it integrates with ad servers and so on, but the management of that is handled through the CDN layer. And one thing in a broadcaster linear TV mindset, one thing that I like to talk about here is, let's talk about how things scale. So the transcoder, as we know very well, scales with numbers of channels and the bit rate. The origin, however, scales differently. Yes, with the channels and the bit rate, but also if it's pulling content from storage and it's handling requests from multiple CDNs, it's also growing or scaling in line with the audience or the library size, generally both. And then the storage itself is scaling according to how much recording is happening of live channels, how big the VOD library is, how long a window of look back is allowed to go back to, for the audience to consume content that's maybe in the last 4 hours, the last 8 hours, and so on. Whereas the CDN side, the edges, they're really, and I know it's not multicasting, but they're performing a similar function. They're proliferating streams from within their environment, therefore allowing an edge cache to potentially handle thousands of simultaneous requests for the same piece of content, let's say, like a live event, and therefore have a few streams coming in and potentially thousands going out. So what the edge scales with is the growth of the audience. You know, are we going from 1 million customers to 2 million? That's a growth in the size of the edge environment. As well as the bit rate. Is the average bit rate going from 3 megabits per second to 6 megabits per second? And that again would cause a doubling of edge cache capacity. But one thing that's important to note is that edge cache doesn't scale with the increased length of individual content consumption. So if I watch for 1 hour or 2 hours, it's the same output from an edge capacity point of view. But what's interesting, and one of the key principles of how this works is, if I watch 1 hour at 5 megabits per second, I basically stream to myself 2.25 gigabytes. If I watch for 2 hours at the same bit rate, of course I stream double. It's double the output, but it's the same capacity. And that's a key thing to think about when it comes to how the CDNs work and how do they scale. So this picture is effectively showing you in a different way what I've just explained. That an OTT network will have the content origination point on the left. It will be feeding potentially multiple CDNs. That's not always the case, but let's assume for now multiple CDNs, delivering the same content to those consumers who are requesting it across multiple ISPs. And there's the peering point in the middle, where these many-to-many relationships connect. And one of the elements in this network architecture is that it's a shared network environment in every single place that you see here. So which is why we reference now congestion points, because what we're seeing as traffic grows is congestion. And take this as an example. If I have 1 million people consuming content at 5 megabits per second average, that's 5 terabits per second. They request that content across the ISPs into the CDN. The CDN may request that from the origin environment, and then pushes the 5 terabits per second on demand into the peering point, which of course generally will be set up for the capacity that's expected. But what is happening today more and more as the OTT take-up accelerates is that the throughput is being squeezed, and you'll see we're seeing peering point capacity problems. And some of the things that hit the headlines in the last couple of years, as we've had bigger and bigger events in OTT, is caused by this problem. So what do? What's happening, and what have some of the biggest players already done? Just to make the point, sorry, that you know, when we think about the challenges of the OTT operator here, they're trying to deliver all that content to their consumers, but they're faced with these problems, which is they're not in charge of this network. It is a shared environment. They are one of many users of the infrastructure, because this is handling all of the internet's delivery to the consumer base. And it's difficult to control what's happening. It's difficult to optimize their return on investment. And it is difficult to protect their origin, even if they're in a multi-CDN environment. When we've got requests coming back, it depends how those CDNs operate. So as the OTT operators get bigger, these become real issues. So what's been commonly termed the Netflix model, and titled here as well, Hybrid CDN, is one of the things that's designed to solve for this problem. And it's what Netflix did, which is effectively putting a private CDN, private caching, inside ISP networks, which effectively does a few things. So in that consumer experience, those terabits of requests come in. And while, yes, there is a callback to the origin where content does not exist, and perhaps an intermediate cache layer could provide the content, ultimately, the majority of the content gets streamed from within the ISP's network, within the managed network environment, and is able to go through to the consumers much more easily, with much lower latency, with higher performance, maintaining its bit rate. And this is a key factor in how moving edge caches closer to the consumer is able to overcome some of the challenges that we see in the infrastructure today. So what does it deliver? A few things, actually. The origin gets protected because we're handling the caching from within the ISPs, and we're trying to consolidate the CDN delivery into an owned platform or a managed but private platform. We're not seeing constraint now at the peering point. This is a win-win for the network operators and the content providers because they're not having to hit the bottleneck at the peering point. And then in the case where those OTT operators have done this, we end up with closer partnerships with the ISPs. At the end of the day, it's a shared consumer customer. We have more predictable performance. And one of the interesting things is, as those of us working in the internet environment know, expanding network capacity isn't immediate. It takes time. Sometimes it can take a long time to build up the business case to make a big investment in capacity. And if an audience is growing in OTT very quickly, it may be taking too long to expand that capacity. So by going after this approach of trying to embed your caches inside the ISPs, you can actually expand your CDN capacity quicker. One of the questions that, of course, comes up in this, especially amongst broadcasters when I'm speaking with them, is the relationship to the ISP and the fact that that's a new relationship often, especially for streaming video. But of course, the big players have already done this. And the good news here is many countries, which of course is where most content is being delivered by rights owners, broadcasters within those countries, is that there aren't that many ISPs to cover usually more than 80% of the consumer base. And these are the key partners that need to be present for the streaming video service in order to ensure that the quality and indeed even the cost is managed. So just a quick point to note that in terms of deployment models, this concept of the private CDN, it can be deployed inside the ISP, which we see on the right with some household names shown there. But also it can even be deployed today within the environment where we do find the CDNs interconnecting. So there's a few names of examples such as Interaction, Equinix, of course, the data center operators, and then Links, the London Internet Exchange, or MIX, which is the Milan Internet Exchange. These are bodies that can create connectivity. They're the ones that operate the peering point, so to speak, and create that meet me room environment so that the ISPs and the service providers, whether that's a video service provider, whether that's an esports operator, whether it's a cloud service provider, they can all interconnect. And it's possible to deploy in both places and actually obtain some of these benefits of avoiding congestion as that video is streamed to an ever-growing audience. So a quick comment on economies of scale, because that is a key factor as we move forward. I mean, we see the growth in OTT. We know that it's a way forward that is just going to continue to accelerate. But what about the cost of it? And a quick mention here that in models 1 and 2, as I've just talked through, we're really looking for some new business models that can help to overcome both the congestion points, but also provide more cost-effective ways of delivering. And so when OTT operators are getting big, and if we refer to the ESL example from yesterday with Stephen, 1 million consumers watching a piece of a live event, for example, that's a pretty big audience. And the costs of running the CDN service can stack up. So what we often see today is people are paying at this point for the CDN delivery into the peering point. What we're talking about with the concept of the private CDN is that there's less delivery into the peering point and the real delivery gets made from within the ISPs. And so the cost can be controlled in this way. And the other point there to make is that when we talk about capacity, there's two ways of selling CDN solutions. One is per gigabyte delivered, which is the very popular way. It really helps when it needs to be a variable cost and when it needs to be sort of a business has to be launched and the OTT service has to take hold. As we get to scale, and just as Netflix did, just as Facebook have done, the big streamers, it makes sense to try and get the economies of scale by moving to a different model and buying capacity rather than output. And that is where the private CDN model creates an opportunity. And to finish this point, generally we do see a difference in economic outcome and return on investment when we think of a private CDN versus pure public CDN as OTT services get bigger and bigger. And it's something that has to be thought about carefully, I think, in the future as OTT operators grow. On that point, and these are two documents that Vecima has produced, and on the right, we produced this one in conjunction with our friends at the Broadcast Bridge. We're talking about OTT at scale, so the things I've just talked about are referenced in this document on the left. But in the document on the right, Hybrid CDN, where yes, the coexistence of public and private, which is so common, or on-prem and cloud, if we want to call it that, they can be brought together. And that's referenced in that essential guide. But also in the essential guide is talking about the journey from being a newly launched OTT service to being a very mature, high-scale OTT service. And what you see in front of you in this quadrant, with maturity on the left and scale on the right, and of course, looking from bottom left into the top right, we have the journey, let's say, is we know that there are some pitfalls and some opportunities that need to be addressed as OTT operators move through the transition as they develop. So what normally happens is that after launching the OTT platform and getting an audience going, is that we see that we have a best-in-class, what CIRR means, connection-induced rebuffering ratio, and thundering herd, which refers to the concept of thousands, potentially millions of people joining an OTT stream simultaneously. Those problems exist for all the OTT operators as they start to grow. And they have to tune and tweak the parameters within the platform in order to optimize the path, in order to manage the memory and the storage capacity and the network connectivity between the servers within the CDN, look at how the player on the device actually handles the requests and the buffering and so forth. Typical problems which everyone has to deal with, whether you're live or VOD-based services. And generally speaking, as you grow, you deal with those things, the performance of the service remains strong, and then you move into a higher scale. At the higher scale, what we generally see next is that there are two problems. One is an OpEx cost, because we're now getting to a point where this is repeatable, large audiences, particularly when we think about broadcasters delivering OTT. When we're talking about live events only, and they're periodic live events, perhaps like an esports event, then we can deal with big audiences infrequently. But there becomes a frequency level when it makes sense to start dealing with an OpEx cost and turning it more, not into necessarily a CapEx cost, but something that's more fixed. And at the same time as that, we then see the need to engage closely with the ISPs, those businesses that are ultimately transporting the bits and bytes across the last miles. And that becomes a trend, whether you're live only, live and VOD, or VOD only. What we then see next, and this is the typical thing if you think about Netflix and other on-demand platforms, is that delivering on-demand video at very high scale puts huge stress on the storage. And that storage is both a mix of the caching in the middle, in the CDN, as well as the central storage where a library of content resides. And so to ensure ongoing performance, the ability of the storage to record, ingest, stream, handle on-demand requests simultaneously with an ever-growing audience is a key factor in how these services are able to scale. And it has to be addressed in order to really reach scale. And then finally, the one that, of course, those of us having worked in linear broadcast look to as something we know very well, you come to the live story. And of course, live, and I'd say here, live moving into advanced live, let's call it, has the need for performance with latency management, ideally low latency, but also the experience that we're all used to now from having a set-top box in the house and knowing that we can pause a live stream, knowing that we can rewind, we can look back in a schedule, and we can start playing a piece of content that we missed in the previous hour. The ability to even have tailored ads within a platform. These are features of an OTT service that have to be developed and created, and they create a parity with that set-top box viewing experience, which actually is one of the things that many OTT services still haven't achieved yet. And it's something that I think more and more consumers are going to be expecting as we go forward. So let's come on to the final piece and just a few predictions, for some which I feel pretty strongly about, some which are taking a best guess at this point in time. But let's take two examples of things that are giving us the trend. So the iPlayer, we know it very well. It's one of the major OTT platforms in the world. And if we look all the way back to October 2009, the BBC reported that there were 46 million requests, and they delivered approximately 7 petabytes of content 11 years ago. May 2020, which admittedly is in the middle of the COVID situation, there were 570 million requests made. Huge demand on the platform. The estimated amount of content delivery wasn't reported at the time, so that's my best guess, which would assume the bit rate has doubled since 2009, which probably wasn't a bad guess. And if that was the case in May alone, and if we think of the whole year, potentially the iPlayer may deliver about 2 exabytes of content over the course of 2020. And if that was the case, we're talking about 0.1%-ish of global internet traffic, if we're also basing our view on the Cisco forecast. So some interesting potential figures there. But just imagine this as well, that if we had a prime time audience from the UK, so let's say 20 to 25 million people, in a typical viewing pattern where most content is watched in the evenings, there's more at the weekends, the CDN load at 5 megabits per second per stream would be a peak throughput of 115 terabits per second, roughly, which would approximately deliver about 50 exabytes a year. So these are numbers which we're not even seeing anywhere near to today, but the 2 exabytes and the 50 start to make us think, you know, what's the pathway going to be to this sort of scale? And then from another perspective, the global trend. So Cisco's most recent report that looked out to 2023 referenced these sorts of numbers. So thinking about internet usage, ultra high definition TVs, number of Wi-Fi hotspots, the average broadband speed, everything's going up. But one thing that report didn't do was talk about what's the prediction on the number of petabytes or exabytes of delivery of video. So my own estimate would be maybe 4 to 5x today, what 2020 is seeing, could be achieved given those figures by the time we get to 2023. So if we're at approximately 2,000 to 2,500 today, maybe we're talking about 10,000 exabytes over the next few years, which is, again, something that we need to think about. And when it comes to video delivery over the internet and the quality of that service that we're delivering to end consumers. So the final slide and you know, the future, what could we expect perhaps? And I really think OTT is truly going to go to scale, even though it's already getting big in certain pockets. It's at the beginning of the curve. So coming back to our picture of the Cisco forecast for 2021, well, imagine if we do hit that 10,000 exabytes by 2023, the curve is still going up. And let's just picture this idea that we have that primetime audience in a country that happens to be watching the majority of its content on the OTT platform, well then that would potentially be the 50 exabytes of content delivery. So when is that going to happen, and how much might that be, and what is the growth? So if that were to happen, it would be about 62,000 exabytes being delivered around the world. It would be about 30 times what we have today. And who knows when? Could it be in this decade? Difficult to say, but based on the current projections on growth rates and trying to anticipate the consumer trends and the way the networks are being expanded and the way people are engaging with OTT services across esports and video, then this is, I think, one of the realistic expectations that we might have about how OTT is going to grow in the future. And with that said, thank you very much for your attention.
Thank you, Paul. I will just pull up the Q&A here. Thank you for the presentation. We do have some questions coming in from the audience, but for those of you who are watching live, please do go to the Q&A area and put in your questions for Paul. So, Paul, first question. What monitoring tools do you use and what do you measure?
Okay, good question. So, yes, so within, let's say, the Vecima environment, if you're within the CDN, then we do have our own monitoring solutions that are looking at effectively the ingress of all the streams into the edge cache from the origin and the egress of all the streams to the end consumers. And so you're really monitoring a few things. One is the streams themselves. Where are they going? What type of devices are they serving? What are the bit rates? What are the patterns of bit rates? And then on the actual CDN servers themselves, you're monitoring the memory usage, the CPU usage. You're checking that you're not overloading any particular part of the server as it's handling the various types of content that are being requested. So inside the CDN, that's what's happening. But of course, at the client end, where the consumer is actually holding their device, then we're looking at, or I say we, the OTT operator who's actually providing that client device or client application can use tools that are embedded in the application. And they're looking at the stream that's incoming from the network that's delivering it. And yes, they're looking at the rebuffering ratio. They're looking at the bit rate. And they're trying to make sure that the quality of the performance is being sustained to that device. So just maybe to mention a couple of names perhaps on that side of it, companies like Conviva, nice people at work, these are the types of solutions that are used on the client side.
Thanks. Next question. You mentioned bandwidth on demand. Mm-hmm. How quickly do requests for bandwidth on demand respond? Do you have to book it days ahead?
So if I'm thinking of the Vecima scenario, it's not quite, let's say it's not bandwidth on demand. For that scenario, we're talking about a large OTT operator who is planning their capacity, and they are able to forecast audience consumption effectively. And so there is a planned expansion of a platform in that regard, which has to take place on a managed way, because at the end of the day, servers have to handle more output. If extra hardware is available, and now we're talking about the potential for both public CDN and a private CDN environment, then we've got the possibility of adding additional capacity almost immediately. So as long as the hardware capacity is available to handle the extra throughput, then subject to how the CDN is set up for handling provision of capacity, then it could be instantaneous, it could be days in advance, yes. And of course, if we're talking about a request for live event and saying, I'm expecting 1 million people to watch my event next Saturday, can I have capacity please? that might not be an easy conversation for many of the CDNs to have because that's a big audience and it depends if that capacity has already been booked or not.
Thank you. Next question. As more live sports are being carried over OTT services, and live sports, of course, includes esports, have you been asked to deliver low latency distribution using tools like a web RTC for delivery, fast packet switching, or quicker transcoding?
The short answer is yes, we have been asked. And yes, we are working on those things with various customers who want that. I would say that, and I think that's a worthy subject for a follow-up call for the audience or a follow-up discussion, is that WebRTC conversation. Is it worth using it? We don't think it is. We think the latency that comes through the transcoder needs addressing, the latency that comes through the packager needs addressing, through the caches themselves, and then ultimately on the player to handle, sub segment sizes, so less than a 1 second packet sizes, for example, that's the important bit of work that has to be done to really achieve what we talk about as ultra low latency. But yes, I think many people are trying to hit the benchmark of the set-top box kind of cable telco experience. So let's say 5 seconds or 8 seconds of latency in total. That's the mission at the moment for most OTT operators dealing in live events. But it does take a lot of work and working within the standards in order to handle the integration points throughout the chain that I've just talked about.
Follow-on question on the same topic. So where do you think ICEVC, MPEG-5, AV1, and BP9 fit in with this?
I'm sorry to say that's probably above my my level of knowledge to respond to properly, but happy to provide a comment back to whoever's asked that once I get back in touch with my more technical colleagues. So yes, apologies.
Fair enough, thank you. Next question. It sounds very much like Twitch, which is focused on many broadcasters to smaller audiences, creates challenges. What is done to scale that sort of broadcasting?
Yeah, so firstly, when it's a small audience, and depending on where the audience is a key question. Let's imagine two scenarios. Many of the typical audiences we think of are domestic audiences. They're living within an area where there is the right to distribute the content. So most of the broadcasting that we're used to has to deal with a domestic audience. Some, of course, deal with global audiences, and those have a different set of challenges. So let's assume on the first case, we've got domestic audience, multiple channels to smallish audiences. It shouldn't be too complicated, I should say, to be able to scale out that platform, because it's all about how the CDN itself is able to bring the streams in and then proliferate them to the consumers. And as long as the CDN architecture is set up efficiently, then most of that traffic, especially live, should be deliverable from the cache themselves, as I was describing earlier. And the caches themselves will be inside the territory of the country that's being, where the content's being delivered. So it would be interesting to see if there's a specific scenario someone's got there that is a problem case that may be needing closer looking at. I think the global scenario is one that only the global CDNs can support. And it's all about how that global CDN infrastructure can be taken out to those markets where the audiences are. And if you have an audience that's split up all around the world, then that CDN is going to be, or the CDNs used will be the partners to make that happen. But between the origin, delivering the content out from the platform, and the CDN pulling it, caching it, and proliferating, there just needs to be the right level of, I would say, capacity allocation, network setup to make sure that there aren't any problems with the quality of the delivery.
Thank you. Next question. How does Vecima see the growth of esports over the last few years? Do you have any interesting case studies or stories you can share with our audience on esports and your CDN?
So that's a really interesting point, because I think when we heard, firstly, we heard Stephen Jalisi talking yesterday, and of course, esports growth and what he's seen with the audience size and how many events they're running and how big those events are. They've dealt with the need to push the content from their points of delivery. And they've gone to the platforms, and the platforms being Twitch, etc. And then those platforms are obviously dealing with the public CDN service providers. Now, Vecima, as a CDN, I'm going to say manufacturer, we actually are a software developer, is embedded in all sorts of different environments where the traffic is being streamed through our edge caches. But we're not offering the edge cache service as a public CDN, which Twitch and the likes of Akamai, Limelight, CenturyLink and others are doing. So what we do see, as opposed to a very specific esports experience, is what happens with live sports, traditional sports. And of course, those do have their peaks, significant peaks that we see, even basic things like football, which of course has been available on OTT for many years. Our customers have to deal with the fact that on a Friday night when the game's on and it's on the OTT platform, they have to deal with a peak in the OTT platform, which is 10x, 15x the normal OTT traffic. And that needs clever capacity management. And I would say that the thing that has to happen in the CDNs in order to handle this growth is the density and power of the cache to handle more and more streams, and then the placement of that cache in terms of as close to the consumer as you can get it. Those are the things that are naturally evolving as whether it's a live traditional sports or live esports scenario is occurring. But yeah.
One of my favorite topics, 5G. Question from the audience: how dependent is delivery on the implementation of 5G, and where do you see 5G transforming or affecting CDNs in the future?
So yeah, it's a very interesting question. It's something we look at a lot within Vecima. When we talk about 5G and we talk about the numerous number of smaller points of delivery within a mobile network, naturally, as consumers, when we're on our devices, we're going to be connecting to them. We're going to be streaming the video. How the content is able to be proliferated within effectively can be an unmanaged network, which is what OTT is crossing, is something that's of interest. So do we see smaller and smaller edge caches being pushed closer and closer to consumers? Possibly. Yes, that's one scenario. Getting close to those 5G masts or very small towers that will be deployed. I think it's just going to expand the capacity for people to stream at higher bandwidths, for more advanced services, be more engaged with ways of handling the viewer experience. So on the one hand, I'm sure it's going to contribute to the growth of OTT video delivery. On the other hand, I think that the CDN infrastructure will just generally make this move towards edge computing, and the closer to the edge you can get, the better. But there are today trade-offs between how many boxes, how many servers you need to put somewhere to be the physical server, the physical compute, the physical storage versus the centralized model. And so today the norm, although if we go back 10 years, a CDN was all about pushing VOD content to the edge, replicating content so that it was close to the consumer. It's then become centralized storage with clever, intelligent edge caching, and how close you go to consumers is the only question. And I think that's where we're going to see an evolution over the next 5 to 10 years of perhaps smaller and smaller edge cache capabilities.
Thank you. Well, that comes to the end of the audience Q&A. Thank you to everyone for putting in your questions. Thank you to Paul for the presentation. We have one more session of the Esports Broadcasting Colloquium tomorrow, 5 p.m. British time. And we will be hearing from Guillaume Neveu from EVS on how EVS works with esports and broadcasting. So please join us if you can, back here, same time tomorrow. And again, a very big thanks to Paul Martin from Vecima for his presentation today. Thank you.